Okay, we're going to do the limiting reagent reaction. In this reaction, we're going to be reacting copper sulfate, copper 2 sulfate, CuSO4, with aluminum metal. So the first thing I'm going to do, this is anhydrous copper sulfate. It's kind of a white powder, maybe very slightly blue, but mostly white. And I am going to get a weigh boat. Turn it a little bit. Okay, the first thing I'm going to do is tear out my weigh boat. And I want about 2.5 grams of this copper sulfate. So let's get my arm out of the way. So I'm going to pour it into the boat. Not quite enough. So let's put a little bit more. Now, it doesn't have to be exactly 2.5. I want it to be around 2.5. Not quite there yet. But what I do want is, maybe a little bit too much. But what I do want is it to be exactly known. So it doesn't have to be 2.5, but it needs to I need to know exactly what it is. So 2.539 grams is my copper sulfate. And while I'm here, let's go ahead and weigh out the aluminum. So I'm going to get a second weigh boat. And I'll zero it out again. Well, those two weigh boats weigh the same. Often they don't. So we've got a 0. And here's what the aluminum looks like. It's just like aluminum foil, but it's shredded. So it's just really tiny shredded aluminum foil. And the aluminum I want to have somewhere around 0.2 grams. So way too much. Let's take some out of there. All right, I'll take a little bit more out. All right, that's probably good. So the amount of zinc that I have, let's close both doors so we have no airflow, 0.219 grams of aluminum. So you should record that, record that in your table. Here's the sheet of paper there. Let's move this out of the way. Okay. Okay, so what I'm going to do first is I'm going to put the copper 2 sulfate into a beaker. Let's make sure we get it all. I'm going to add water to it. You notice that water, copper solution tends to be blue, so adding that water has made that solution blue. I want to make sure and get all the copper into my beaker, so I'm going to rinse my boat. Whoops, you couldn't see that. I'm rinsing my boat off. I've got a stirring rod here, and I just want to make sure everything is dissolved before I do anything else. So I want to make sure all of my copper sulfate goes into solution. And one way that I can do that, I'll move this over here a little bit. One thing I can do is I can put it on a hot plate. So agitating will help things dissolve a little better, and then heating them up tends to make things dissolve better. So I'm going to heat this up, and I'll come back as soon as it's all dissolved. Okay, so that solution is nice and clear and light blue, so you should definitely record that. And remember, the powder was white before I added it to the water, and now it's kind of a light blue. Now I'm going to add my aluminum. So same as before, I want to make sure the amount of water doesn't matter. So same as before, I want to make sure all of the aluminum that I weighed gets in there, because I want to, this is a calculation problem, and I want to know exactly how much reacts, and so I want to make sure and get it all in there. So now I've got it in there. And if you look, I'm going to have to squirt it down in there too. So the silver's in there, but then something is starting to look a little brown. So let me start stirring it. Some of that silver is disappearing, the silver aluminum. So what's going to happen is the aluminum is a metal, And this is a redox reaction, and so the aluminum is actually going to go into solution, so it's going to become the ion. You can start to see some brown there. The copper, which is it's an ion right now, the copper 2 ion, which is in solution, copper plus 2, is in solution, and it will become copper metal. And you can actually already see it down here. Let me get a paper towel, if I can find one. You can already start to see that there's something that's forming at the bottom, and it's more of a coppery, oops, you can't see that because I lifted it out of your way. It's sort of forming at the bottom, and it's more of a coppery color. So I'm going to let it react for a few minutes, make sure everything gets reacted, and I'll check back in a few minutes and show you the progress. So it's been about four minutes or so. See if I can show you what it looks like. You can see that most of the silver is gone, and now it's all that kind of brown coppery color. The solution itself is a little bit more muddy, so it's not as blue. Here's the original solution with sort of that blue color, and now this has become more muddied. So the reaction is proceeding, but I want to give it plenty of time to make sure all of the aluminum and copper have reacted. Now, one of these is the limiting reactant, and that's what you're going to figure it out by the time we're done. So one of them should we want to make sure that that one, whatever's limiting, gets all used up. Okay, it's been about 7, maybe 8 minutes, and I think we're done. I wanted to show you what the solution looks like. And you can see, so it's much more muddy, still a little bit blue, maybe blue-green. And if you look on the bottom, you can see that there's a whole, let's see if I can show you that. Let's see if I can do that. You can see on the bottom of the beaker, there's a whole bunch of brown gunk. That's the copper that has formed, and that's on the bottom of the beaker. So I'm going to let it cool down for just a little while. And then what I'm going to do is I'm going to filter it so that I can collect all the copper, so that I know how much copper was made by this reaction. So while I am waiting for that to cool, let me show you the setup. Okay, so what we're going to do is we're going to filter out the copper, and we're going to use a funnel into an Erlenmeyer flask. Erlenmeyer holds it well. And what we need to do is use a piece of filter paper inside the funnel so that we can catch the copper. So before we do that, we want to weigh the filter paper. So let's move you around here. Oops, let's first make sure and zero it out. Okay, zeroed out. I'm going to put the filter paper on the scale because I want to get a good reading of it. It is 0.991. So the filter paper is 0.991 grams. So I wrote it over here in case you need to see it. And then what I'm going to do is I'm going to fold the filter paper. Let's see if you can see it. I'm going to fold the filter paper in half, then in quarters. And then what I do is I open up, I put 3 on one side and 1 on the other. So it opens up like a little, because you don't want it slipping through there. So you want 3 on one side, 1 on another. And then you stick it down in there. You move over here. See if we can see it better. These lights are a little bit glary. All right, one thing to keep it down is you can squirt a little bit of distilled water down in there, and the paper will stay in there. Let's see if we can get that zoomed in a little better. All right, and then what I want to do is I want to filter out my filter out the copper from this solution. So let's give it a good swirl. And again, I'm going to clean everything off because I want to collect as much as possible. So I'm going to filter this through there. Just takes a little while to drip. And you can see, I think you can see that there's some of that copper is going to stay in the filter while the liquid, the liquid drains through to the bottom. So we're separating the solid and the liquid. All right, I'm going to pause it while I, do some more. There's a lot to filter here. I still have a lot of solid down in my beaker, so I want to make sure I'm going to swirl and make sure I get as much as I can into the filter. Still have some in there. So what I'm going to do is make sure and I'm squirting some water down in there to make sure I get as much of the copper as I can. This is called a little rubber policeman. I can scrape some of it out and make sure I've got it all. As you can see, I can't get every single bit, but I'm going to get as much as I possibly can out of the not the easiest thing. All right, I think I got most of it out of the beaker, and I'm just going to rinse my little container here. Rinse that down so it's not on the edge. All right. Sometimes it gets a little stopped up and you got to kind of lift it so that it continues filtering. So let me pause it again and make sure, give it some time to filter. All right, so pretty much, let's see if we can see that. Pretty much all of the water has drained through. Yeah, let's get that. And you can see it's a coppery color. So that's the copper that has formed. It's still a little bit wet. You can also see the color of the solution that came through is a little bit blue still. So that's a little hint about, probably should tell you what the limiting reactant was. Anyway, that you can figure that out for yourself. So what I'm going to do, it's the copper that I want to weigh, but unfortunately there's still water in there. It's still wet, and if I weighed it right now, it would add the weight of the water. So what I have to do, I'm going to open it up a little bit so that it will dry better. And I'm going to put it on a watch plate here. I can see all that copper. And now what I'm going to have to do is dry it. Dry the paper, make sure all the water evaporates. So you can see it there. We want to make sure that this paper is totally dry and that all the water evaporates. And then we will weigh the copper and we'll see how much product was made. All right, so finally, I let the paper with all the water, it dried in the oven for probably about 20 minutes, maybe a little bit more. And let's zero it out. All right, now I'm going to weigh the filter paper along with the copper. All right, and it is 1.770 grams. So obviously, if the filter paper with the copper is 1.770, you have to subtract off the weight of the filter paper and you can get the weight of the copper. The rest of the lab, you will have to figure out what the limiting reagent is. You have to figure out how much of the other reactant was left over. And we also are going to determine the theoretical yield and the percent yield. All right. So happy calculating.